Okay. Um, anyways, we're looking at the quiz, first quiz of the year. I'm having ChatGPT compose an answer key just to double check I'm doing it correctly, but we'll give it a go. All right, it's coming up now. All right. Anyways, first problem. They're talking about the associated property, the commutative property, and the inverse property. And then you have to match everything. So for the most part, they're like in pretty good order, but the associated property, ASO, is, our regrouping. So it's going to be like 3 times 4 times 5 is equivalent to 3 times 4 times 5. So this is our associated property. We regroup things. Number 2, or the second part of this, the commutative property. Commutative property, wow, means we can change the order and still maintain equality, like 3 plus 5 is equal to 5 plus 3. Not bad. And then this inverse property. Inverse property, we got 3 times 1/3, and 3 times 1/3 is 1. Basically, the inverse property, because there's an inverse property of addition and multiplication, you go back to the identity. So like the inverse of addition would be like 3 plus -3. You go back to the identity. That took a minute. We might be in trouble here. All right, 2. We got 4k minus k over 5 is equal to 3k plus 7. Don't know how I'm going to do this one. I know I don't like fractions. I'm going to move k's to the same side, so I'm going to subtract 3k from both sides. Subtract 3k from both sides, and I'll get k minus k over 5 is equal to 7. I could see at this point multiplying both sides by 5, but I do look at this and just say, like, I got 1/5, and I'm taking away from a whole. So this should be 4k over 5, or 4/5 k. Maybe we can think about that. 4/5 k, which is equivalent, is equal to 7. And I'm going to multiply both sides by the reciprocal. So I'll go 5/4 times 5/4, and I'll get k is equal to 35 over 4. That's my answer. That's not terrible. Is what it is. All right, on to 3. 3 says 3 times 2k minus 4 plus k is equal to 2 times 3k plus 5. Go ahead and distribute everything. 6k minus 12 plus k is equal to 6k plus 10. Ooh, I guess this is nice. Look at there's 6 k's on both sides, and so normally I get the k's all on the same side, but these k's are definitely going to cancel out. Like if you subtract 6 k's from both sides, they'll cancel out. And then I'll get rid of the 12 by adding 12 to the other side, so I get k is equal to 22. That's pretty doable, and I think I'm still getting the right answers. On to question 4, and we're making pretty good time now. Q is equal to 2kr over r minus 1. We're solving for k here, I hope. Yep, solving for k. Man, yeah, in this one, I'm definitely going to get rid of fractions. Don't like the fractions. So I'm going to multiply both sides by r minus 1. So I get r minus 1 times q is equal to 2kr. Okay. I'm solving for k again. I'm kind of forgetting for some reason. K is not by itself. There's a 2 there and there's an r. And at the same time, I'm going to divide both sides by 2r. And I'll get k is equal to r minus 1 times q over 2r. On to the next problem. 5. Okay, I'm liking this pace. I get 3k minus q over 2 is equal to kp minus 8. This is like our first hard one, maybe? I don't know. It looks hard. We'll see, though. I'm going to multiply both sides by 2. I get 3k minus q is equal to 2kp minus 16. Again, just limiting fractions. I'm going to get the k's on the same side and everything else on the other. So I get 3k minus 2kp is equal to q minus 16. I'm moving the q on the other side and the k's on the left. Now, no matter how hard you try, you can't add these. They're not like terms. So I'm going to have to factor out. Basically, undo the distributive property. Distributive property works both ways. So it really is just, factoring is the distributive property. So I get k times 3 minus 2p is equal to q minus 16. And then I divide both sides. I say k is equal to q minus 16 over 3 minus, can't think, 3 minus 2p. Don't try to simplify. That's a different topic. You know, just kind of solving right now. Give me 1 second. 1 second. We're good. The solution actually had it in the, like basically multiplied the numerator and denominator by -1. So they had 16 minus q over 2p minus 3, but it's the same answer. On to the next. We're on to 6. Okay, perfect. Here's 6. It says a line passes through K2, the point K2, and 3K and has a slope of 5. Okay, so we got passes through K2 and 3K and has a slope of 5. Okay. Oops, slope of 5. Alright, so then I get like k minus 2 if I do the change in y over the change in x, 3 minus k, and this is equal to 5. That's not bad. Again, that's how you find slope. Slope's equal to slope. I'm going to get rid of the fractions by multiplying that 3 minus k over to the other side. So I get k minus 2 is equal to 15 minus 5k. Just solve for k here. I'll move k over to the left-hand side. So I'll get a 6k. I'll move the 2 over to the right-hand side, so I get 17. So I get k is equal to 17/6. It's not a nice fraction, but is what it is. Is what it is. Alright, on to 7. Moving along. 7 is a line has the equation k minus 2. K minus 2 x plus 4y, and this is equal to 10, and has slope of -3. You want to get this into the slope-intercept form, so we'll go ahead and do that. Slope-intercept form, we're going to get it into this y equals mx plus b form. So I'm going to subtract that thing over. So I'll get 4y is equal to negative k minus 2 x plus 10. I don't really care about the b part. I just need the slope. And then I'll solve for it by divide by 4. So I get y is equal to negative k minus 2 over 4x plus 10 over 4. Again, I don't really care about this value. I just care about this. Well, that's my slope. All right? And they tell us our slope is -3. So I'm going to say negative k minus 2 over 4 is equal to -3. And then I'll say negative k minus 2 is equal to negative 12. I divide both sides by a negative value. I get k minus 2 equals 12. I get k equals 14, but let me double check my answer. I don't know if I like, yep, k equals 14. We're good, we're good. Moving along. Man, I don't like, well, let's do the next one. I'm not complaining. Alright, 12. Let's see, this is number 8 actually. 12 plus the absolute value of x minus 2 is greater than or equal to 14. This is equivalent to x minus 2 is greater than or equal to, I believe that's 2. I think that's the first trick, is like isolate the absolute value and then determine whether this is a conjunction or disjunction. You know, is our solution set going to look something like this, something like this, or is our solution set, the distance from 0, going to look something like this? Like, which one is it? This actually is a disjunction. There's going to be like a hole in our solution set. Again, this is the distance from 0 is greater than 2. So, anyway, I'm going to continue here. We're going to get this into a disjunction. X minus 2 is greater than or equal to 2, or x minus 2 is less than or equal to negative 2. And then solve. X is greater than or equal to 4, or x is less than or equal to 0. I think that's correct. And then as a solution set, and I think this is like easier to do, as a solution set on the number line, this is my answer. That's one solution, which is this guy over here. And then my other solution is this guy. So in interval notation, this is negative infinity to 0, union 4 to infinity. And I have to include these actually. On to the next. That's number 8. Yeah. Number 9? Looks like a typo. I don't know why. I don't know. Let's see. Absolute value of 3x plus 2 plus the absolute value of 3x plus 2 is less than or equal to 10? I can't tell. Less than or equal to 10. That's what I'm going to say. I mean, it's not terribly difficult. If I take something and I add the same thing to it, you get 2 of those quantities. So this is equivalent to 2 times 3x plus 2, which is less than or equal to 10. I divide both sides by 2, so I get the absolute value of 3x plus 2 is less than or equal to 5. And that is a conjunction, so I'll go ahead and write my conjunction. This is saying that this inside 3x plus 2 is going to be in between 5 and negative 5. And then I'll go ahead and solve this conjunction. I'll subtract negative 2 from each of these. So this will be negative 7 is less than or equal to 3x, which is less than or equal to 3. And I'll divide everything by 3. So this is negative 7 thirds is less than or equal to x, which is less than or equal to 1. There's my interval notation. Well, I guess I got to write interval notation. So on the small side, this is negative 7 thirds, and on the other side, this is just 1. I'm going to double check my answer though. I don't want to mess up. Why do I guess, oh no, we're good, On to 10. Man, you know, not crazy about 10. But I'm going to do it. All right, 1 is less than or equal to 2x minus 1, absolute value, which is less than or equal to 5. Like right now, that's a conjunction. So you can break this up into two equations using the keyword and. And those two equations are 1 is less than or equal to the absolute value of 2x minus 1, and the absolute value of 2x minus 1 is less than or equal to 5. And then you can solve each one of these separately. So let's do that. Like, how do we do that? Well, this means 2x minus 1 is greater than 1, or 2x minus 1 is less than, I'm losing my equals to, less than or equal to negative 1. And then solve each one of these. So this is 2x is greater than or equal to 2. X is greater than or equal to 1. Or 2x, which is less than or equal to 0. X is less than or equal to 0. And on the number line, right? So here's my critical values. This is 0 and here's 1. We're talking about this solution. So it's like x is greater than or equal to 1. X is greater than or equal to 1, or x is less than or equal to 0. So we're talking about that solution. And then now I go solve this other equation. So unfortunately, this turns into like 4 equations. But this is like 2x minus 1 is somewhere between 5 and negative 5. And then, I just solve this, solve. So I add 1 to both sides. So I get negative 4 is less than or equal to 2x, which is less than or equal to 6. And then I divide by 2. So I get negative 2 is less than or equal to x, which is less than or equal to 3. All right, and then this is the solution here. So this is this solution. So this is negative 2 and 3. So we have this guy right here. This guy's a conjunction. All right, and so our answer, right? Well, we have these two solution sets, but how do we combine them? Is this going to be a conjunction or disjunction? But our original problem was a conjunction. So we have to take where these two overlap. And I think it's easy to superimpose one of the graphs onto the other. So I'm going to do that. So I'm going to say this is negative 2 out here. And I'm going to say this is 3. And so, negative 2 and 3. So our other graph looks like this. I just superimposed them on the same graph. And we want the part that overlaps. Well, they overlap from negative 2 to 0, union 1 to 3. I'm kind of over this problem. I feel like we've seen this a lot, but it's like a lot of work. But it is what it is. Jumping on to the next problem. We are on problem 11. Stuff about lines should be easy. A line passing through the points negative 3, 5, and 1, negative 7. Just find slope. Really basic algebra 1 skill, So I first find slope. So I say negative 7 minus 5 over 1 plus 3. It'd be 1 minus negative 3, but I just kind of went in there. This would be negative 12 over 4, which is negative 3. I'm not done, though, because that's just the slope. I need to find the equation of the line. So I do like point slope formula. I do. But I feel like as a student, I just did y equals mx plus b. I just did this route. And then I did y is equal to negative 3x plus b. And then I plugged in one of our points. So then I got 5 is equal to negative 3 times 3 plus b. I hope I'm doing this right. It looks right, I guess. This is 14. 14, unless I messed up. Let me double check. May have hit a brain fart. Oh yeah, this is negative 3. Yeah, so this is 5 is equal to 9 plus b, so b is equal to negative 4. So you get the equation y is equal to negative 3x minus 4. But man, that point slope is very convenient. The y minus y1 is equal to m times x minus x1. Really convenient. And we plug dot points in there, you know, y minus, I'm plugging in the point -3, comma 5. Plug 5 in here. You get -3 x minus, I guess that would be -3. Yep, -3, which would be a +3. Supposedly you get the same answer. Yes? Yes. Yeah, for sure. Because you get y is equal to, when you distribute this, this would be -3x minus 9, and then when you move the 5 over, it will be +5, and you'll see same answer. 3x plus minus 4, 3x minus 4. That's not terrible. All right, 12. I'm tired already. Parallel line and x-intercept of 2. So we got y is equal to -3x plus 1, and we have an x-intercept of 2. That means it passes through the x-axis at 2, so we have the point 2, 0. We know our line that we want, that we're looking for, is parallel, so it has this, you know, -3x plus b. Now let's plug in the point here so we can figure out what b is. So I'll say 0 equals -3 times 2 plus b. B has to be equal to -6. Actually, +6. It's awkward. And we have the equation y is equal to -3x plus 6. Ooh, I hope. Yep. All right, on to the next 13. Just trucking along. The perpendicular line, the line perpendicular to y is equal to 1/2 x minus 4, and passes through the point 2, -1. All right, so the slope we're looking for is -2. So we'll have the equation y is equal to -2x plus b. Again, perpendicular means it's the opposite and reciprocal slope. I think we need to do a proof to like show why that's true. Yeah, I think so. I'll ask your teacher. All right, plug in the point. Do they give us a point? Yes, plug in the point. So we got y is equal to -2 times 2 plus b. I don't know why I didn't plug in the -1. I get -1 is equal to -2 times 2 plus b. I get b is equal to 3. Yeah, I hope so. Y is equal to -2x plus 3. Like triple checking. Looks good, looks good. On to 14. 14 says the line that passes through the point 2, 6 and 3, 6. I mean, if you just like drew this, you know, like you don't have to do anything. Let's see, 2, 6 is here, 3, 6 is here. This is a horizontal line. No matter what, y is always 6. If y is always 6, the equation is simply y equals 6. With no work. No work. All right, on to 15. I think we're on 15. Yes. Solve the system. X minus 2y is equal to 5. And 4x plus 3y is equal to 9. Well, you can't always get them right on the first try. You know, sometimes. Yeah. I think that like even solving systems, I don't think it's like a difficult topic. Even if there's like other weird variables in there, it's not that hard. You just got to be pretty organized. And like me personally, I'm not that organized. Yeah, I think I'm a little bit of an underachiever. All right. Anyways, I'm elimination, and I'll multiply the top by -4. Excuse me, guys. And when I multiply the top by -4, I'll get the new equation of -4x plus 8y. That's what I forgot to do. Is equal to -20. On the bottom, you get 4x plus 3y is equal to 9. Yes. So you get 11y is equal to -11. Y is equal to -1. Not bad. Now plug that in somewhere. and get a second answer. I'm gonna plug it into the first one. I'm not really sure why. I just am. So I get x plus 2 is equal to 5, and so x is equal to 3. Easy enough. On the 16. Man, I don't like 16. I'm thinking about changing it. Don't know. X plus y equals 2y minus 2. I don't know if they're like trying to troll you with this problem, but don't do this problem like this. There's like a skill in mathematics is like take something we haven't seen and like try to change it into something we've seen before. So like you might want to just like add them, but it doesn't eliminate anything. So I'm going to put all the variables on the left-hand side and then everything else on the right-hand side. So the first equation, I'm going to subtract 2x on the other side. So I'll get negative x minus y equals negative 2. And the second equation, I'm going to move the y over and get x, I hope I'm not mixing up, x minus y equals negative 2. I believe that works. And I have these two new equations, but it'll be solving the system. And then those x's cancel out, and you get minus 2y is equal to negative 4, and you get y is equal to 2 as the answer. But I'm going to check my answer. Yep. And then find that answer, plug it into one of the original ones, and, you know, go to town, I guess. So I get, or actually I'll just plug into one of these. I don't know. They both look not nice. I guess that one. So I get negative x minus 2 equals negative 2. Subtract, or add 2 to both sides. I get negative x is equal to 0, x equals 0. That's whatever. It's not bad. On to 17. Are these getting harder? Maybe. 17. All right, Hannah Road. Let's see. Hannah Road. Hannah Road speeding down a river 12 miles with the current, and it took them 1 hour. On the return trip going against the current, it took 1.5 hours to find the speed of the current and speedy speed. Wow, that's confusing. Okay, but I think speedy is like going with the current and going against the current, one of these problems. So let's actually calculate speed with the current, like their faster speed. They go 12 miles in 1 hour, so their speed is 12 miles per hour. On the return trip, same distance. It took 1.5 hours, so then it's like 12 divided by 1.5 hours. Let's do some side work. So this is 12 divided by 3 halves. Multiplied by the reciprocal. This is 2/3. This would give you 8. So I got x. This looks really familiar. I think this was copied from somewhere. As all problems are. And then do elimination. So I get 2x is equal to 20. X is equal to 10. Okay, that means the current has to be 2. Okay, I mean, this could have been done in your head, I think. Yeah, maybe. I don't know. 18. Let's see, a school sold 120 tickets to play. Adult tickets are $10. Student tickets cost $6. Let's see, so number, let x equal the number of adult tickets. Adult tickets. Adult tickets. I don't know. And let y equal the number of student tickets. All right. Let's see. 120 tickets were sold. X plus y equals 120. 120, and we got 10x. 10x plus 6y equals 1,020. That's not bad. Multiply by -6. Yeah, I'm going to go with -6. I'm kind of regretting it, but -6. We'll see if it works out. When I multiply by -6 on that first one, I will get -6x minus 6y equals, let's see, 12 times 6. 72? Sure. This is -720. Yeah, that makes sense. I'll take that. This is 10x plus 6y equals 1020. I got 4x equals, oh man, 4x equals 300. Why didn't this work out? Why didn't this work out? I wanted nicer numbers. Wait, what am I doing wrong? Oh my god. Wait. I'm gonna continue that. I don't know why I'm not working this out. Okay, so x is equal to 300 divided by 4. That's 150 over 2. That's 75. That's not terrible. That's not terrible. It's not bad. It's not great, but it's okay. That is my x value. So I got 75 plus y equals 120. Subtract, I think y is equal to 45. Yeah. On to the next. I think I'm done. Nope, 19. I got graph the solution set of inequalities. Y greater than 0, and y plus 2 is greater than or equal to 0. I'm going to get these in the y equals mx plus b form, so this transforms into y is greater than negative x, and the second one transforms into y is greater than or equal to negative 2. And then I'm going to graph these. Y equals, I don't know why I'm not doing different colors. Y is greater than negative x. That's the line with a slope of -1 and a y-intercept of 0, so it's this line. And we're doing greater than that, so it's this area. And then the line y is equal to, y is greater than -2 is a horizontal line, which I'm going to do a different color. That's what I said. So it's like this line here, y equals -2. It's the region above, so like our solution set is like this. Oh, it looks terrible. Anyways, well, it would be this solution. So it's above the line y greater than negative x, and it's also above the horizontal line y is greater than or equal to -2. So like that region. Graphing. All right, thank you guys.